All right, so the last thing in section 3.3 that we're going to talk about is finding slope from the equation, and also we'll talk about parallel and perpendicular lines in just a few minutes. So at this point, we have looked at how to find slope of a line from looking at the line itself and literally counting rise and run. We have looked at using the slope formula with also that extra added emphasis of kind of in your mind picturing what this is going to look like. And so the last way that we're going to talk about slope is from the equation. So if you remember back at the first part of chapter 3, I told you that equations have solutions. Those solutions are order pairs. Those order pairs then go on the graph to represent all the solutions of that equation. And so the equations and the graphs and the order pairs, they all fit together. And so we can find slope from all of those. So we can find it from the graph. We can find it from taking a couple of solutions and using the slope formula. Then we can also find it from the equation. And so what we're going to do is we're going to take our equation and try to put it in the form y equals mx plus b. Now, basically what we're doing here is we're getting y by itself. So you're going to move terms from one side to the other. You might have to divide by something, but we're trying to get y by itself. And so if we can do that, then the m and the b are going to be really important numbers. The m, hopefully you know from the previous video, always represents slope. So if we can put our equation in this form, then we can look at that number with x. X is not part of the slope. It's the number in front of the x, the coefficient. That number tells us the slope of the graph of that line. And so if we can look at the equation and find that number, then we know the slope. And so in this first example, the equation is already in that form. It's already y equals negative 7 over 2x plus 1. Well, that's y equals mx plus b. Well, the m is the number we're looking for. We want to know the slope. And so that is, in this case, the negative 7 over 2. And so we're just going to say that is our slope. Now, again, I think it's important that we are able to get this mental picture, because if you can get this mental picture of what it looks like, then in a few minutes we're going to look at how to graph with slope. And if you know what the steepness looks like, then it's just a matter of, okay, where is this on the coordinate plane? And then we can plot that. And so what this slope tells us is that if we have a point on this line, for every 7 units that we go down, 7, we're going to go right 2 units, and we should have another point on this line. And so we get an idea about what our steepness looks like. Kind of looks like that. And then again, once we kind of know what the line looks like, it's a matter of where does it go on the coordinate plane to be able to actually graph the line. And again, we'll talk more about that in just a few minutes. But look at the next equation. It's not in this form already. And so what we need to do is get it to be in this form. Now, you'll remember from earlier chapters in this class, we've talked about how to solve for a variable, how to get x by itself or y by itself. And in this case, what we're doing is we're trying to get y by itself. And so we need to first take this 3x and we need to move it to the other side. And so it's positive, so we'll move it by subtracting it. So we'll subtract it on both sides of our equation. And 3x minus 3x is 0, which is what we wanted. And we get 2y is equal to negative 3x plus 9. And then we need to divide by 2. And every term gets divided. And so now we're going to end up with y is equal to a negative 3 over 2x plus 9 over 2. Well, again, what is our b? Well, this is in the equation, or in the form, y equals mx plus b. The m is negative 3 over 2. Do not tell me that the slope is negative 3 over 2x. That is not part of the slope. The slope is negative 3 over 2. And so there is our slope for this line. Now, again, we want to have this mental picture. So what does it mean? Well, it means if we have a point on the line, for every 3 units that we go down, we can go right 2 units, and we should still be on that line. And so our slope, or our steepness, is going to look like that. So, 3 ways to find slope. Count, rise, over, run. Use the slope formula. Find it from the equation. Now, finding it from the equation, if we have the equation, is very easy to do, as you can see. And so that's going to allow us then to be able to find out if lines are parallel or perpendicular without a lot of issues. So we need to first identify what is a parallel versus perpendicular line. So parallel lines, if I were to ask you that in class, if we were in a room together and I said, what are parallel lines? People are going to start making motions with their hands, and it's going to look like you're directing airplanes or something. I always see people doing their hands up and down, side by side. And what they're trying to tell me is that parallel lines run beside each other. And that is true, but more specifically, they're lines that never cross. They never intersect. And so we may say, well, this line would be parallel to this line. And so we kind of know what that looks like. We have that image in our minds. And so you could look around you, and I guarantee you there's parallel lines. If there's a door beside you, the side of the door and the other side of the door are parallel. The top or the bottom of the door are parallel. If you're sitting by a window, the top and bottom of the window, or the 2 sides of the windows, those are all parallel. If you're sitting at a table that is rectangular shaped, it probably also is going to have parallel sides. And so you can picture that in your head. You can see that pretty easily. The question then becomes, well, what are perpendicular lines? And so parallel lines, we know what they are. Parallel lines have the same slope. And I think I can convince you of that pretty easily. So if you were to think about a staircase, okay, if in our building we're on the top floor, and if you go down the staircase to the bottom floor, you know the staircase kind of looks like this, where this set of stairs and this set of stairs are parallel. Because what happens is the size of the step, the amount the step goes up and over, in both sets are the same. If they weren't the same, then eventually those two sets of stairs would run into each other. And so you could very quickly see that those two staircases are parallel if you look at it from a side view. Same deal on these 2 lines I've drawn here. The amount that you go up and the amount that you go over for both of these should be the same. And so neither one of them is, for lack of a better term, gaining ground on the other one. They never get closer to the other one, because every time they go up, they go over the same amount. And they go up the same amount, they go over the same amount, and so on. And so parallel lines have the same slope. Now, back to my original question, what are perpendicular lines? And so normally when I ask this question, I have students that say, well, they cross. Well, yeah, that's true, but it's more to it than that. So more specifically, then, what are perpendicular lines? And some of you may say, I don't know. Some of you may have a good idea in your mind. So let me give you a couple of examples. This line and this line intersect. They cross. But they are not perpendicular. However, this line and this line, we might say, are perpendicular. And the difference is that these two cross and form a right angle. So perpendicular lines have to meet and form a right angle. And so again, you probably can see several examples just looking around you. If you, again, have a door, the top of the door and the side of the door, where those two sides meet, they form a right angle. We would say that they are perpendicular. Same thing with the window or the table that you're sitting at. You could see that, especially if it has a sharp point that it comes to. Um, you may have tile on your floor in the room that you're in, and you may see lines that run back and forth across the room, and you might see lines that run the opposite direction of that. And where they meet, the corner of that tile would be perpendicular. And so those lines, those grout lines, maybe are perpendicular. And so you maybe can see those around you. And so when we talk about it from an algebraic standpoint, perpendicular lines have what we call opposite reciprocal slopes. Meaning that if the slope of this line, let's just use an example here, is, let's say, 2/3, well, the slope of this perpendicular line has to be negative 3/2. It has to be the opposite sign and reciprocal. Okay, so be careful there. It can't just be opposites, can't just be reciprocals. It has to be opposite and reciprocal. Okay, so that's going to be important in these next examples we're going to look at. So what I want us to do with each of these is take each equation, solve for y, and determine if the lines are parallel, perpendicular, or neither. And so you maybe can solve these pretty easily. What I'm going to do is just rewrite the top equation and solve for y, and then take the bottom one where it is and solve. And so if we were to take this first equation, x plus y equals 6, and we solve for y, well, we're going to subtract x, because again, we're trying to get x by itself. I'm sorry, y by itself. And we have y is equal to negative x plus 6. Now, what's the slope of that line? Well, you should be able to look at this and say, well, the slope is this coefficient, which is a negative 1. And so the slope of that line is negative 1. Now, go to the other equation. Solve for y. So again, we're going to subtract x. And we're going to get y is equal to negative x plus 1. And so again, we've solved for y, so what's the slope? Again, it's that negative 1. So the question is, are these lines parallel, perpendicular, or neither? And the answer here, because they're the same slope, is that they must be parallel. Okay, so there's our answer for that set. Now, go to the bottom set. Oh, sorry about that. So on the bottom set, if we take this first equation, 3x minus y equals 4, and we solve for y, we're going to subtract 3x. And 3x minus 3x is 0, so we get negative y is equal to negative 3x plus 4. And then we're going to divide by negative 1. And so the negative y divided by negative 1 makes that a positive y. Negative 3 divided by negative 1 is a positive 3x. 4 divided by negative 1 is a negative 4. And so again, the question is, what's the slope of that line? Well, this one has a slope of 3. Take the other equation. Again, solve for y. And so we're going to subtract x. And we're going to get 3y is equal to negative x plus 9. And we'll divide by 3. We find out that y is equal to a negative 1/3 x. And it's 1/3 because it's understood negative 1 in front of the x. And so it's negative 1 divided by 3. And then 9 divided by 3 is just 3. And so the slope of that line is negative 1/3. And so our question is, are these lines parallel, perpendicular, or neither? Well, they're not parallel because they're not the same. In this case, they are perpendicular because they are opposite reciprocal slopes. So the reciprocal of 3, if you think about 3 as a fraction, here at the top, is 3 over 1. And so the reciprocal of that, if you flip it, is 1/3. And it is an opposite sign, 3 and negative 1/3. And so because they are opposites and reciprocals, they are perpendicular. And so there is the answer for that one. Now, if we were in class, and what I'd like you to do now is pause the video and go do the same thing with the other two. Take both sets of equations, solve for y, find their slopes, and figure out if they're parallel, perpendicular, or neither. So I'll give you about 3 seconds to pause the video, and then I'll work these for you. Okay. So on the first one, if we take this equation, 2x minus y equals 5, and we solve for y, we're going to subtract 2x. We're going to get negative y is equal to negative 2x plus 5, and we'll divide by negative 1. And we get y is equal to 2x minus 5. And so the slope is 2. Okay. Now, at this point, I always ask, are these two lines parallel, perpendicular, or neither? And I always have people in every single class, every single semester. I'll have somebody will say parallel. I will have several say perpendicular, and I might have a few that say neither. And so I don't answer the question until we get through working it. And so in this first equation we've solved, we found out that the slope is 2. In this second equation, we're going to subtract 2x, and we're going to find out that y is equal to negative 2x plus 3. And then now we can find the slope. Well, the slope of this one is negative 2. And so again, the question is, are they parallel, perpendicular, or neither? Well, they're not parallel because they're not the same. 2 and negative 2 obviously are not the same thing. So because of that, we know they're not parallel. The people that say parallel typically missed a sign somewhere when they divided in this first equation by negative 1. Maybe they didn't change their sign. They left it as a negative 2. Maybe something like that happened, and so they ended up not having they end up having the same slope, and obviously that's incorrect. So they're not parallel. But they're also not perpendicular because the reciprocal of 2, again at the top here, is 2. 2 as a fraction is 2 over 1, and so the reciprocal of that is 1/2. Well, negative 2 is obviously not negative 1/2, and so these two are opposites. They have different signs, but they're not reciprocals. And so these are neither parallel nor perpendicular. Okay? So that is opposites, but not opposite and reciprocal. Now, if you take the last set here, and we again take that equation. Again, I always ask, what are these? Parallel, perpendicular, or neither? And usually I don't have anybody say parallel. I always will have people that will say perpendicular, and I always have people that say neither. And so again, we want to solve and see which one is correct. So again, we're solving for y. So we'll subtract 3x. And we'll get negative 7y is equal to negative 3x plus 35. And we'll divide by negative 7. And we get y is equal to 3 over 7x. It is positive because negative 3 divided by negative 7 is a positive. Minus 5. So the slope of that line is 3 over 7. Okay. Then in the next equation, again, we're going to solve for y, so we're going to subtract 7x. And we're going to have negative 3y is equal to negative 7x minus 6. And we'll divide by negative 3. And when we do, we're going to get y is equal to 7/3 x. Again, it is positive because negative 7 divided by negative 3. And then plus 2. And so the slope of this line is 7/3. So again, the question is, are they parallel, perpendicular, or neither? And sometimes I still have people that say parallel, and I still have people that say neither. And the correct answer is that they're neither, because these two are reciprocals. They are not opposites, though. So the opposite part of it means opposite sign. So you have 7/3 and you have 3/7. They're reciprocals of each other, but they're not opposites. So when you look at all four of these together, I will do the first two with you, and the other two I always tend to let my students do in class, because I want you to see, number one, if you make a mistake, you understand why you made that mistake and don't make it again. But I also want you to see that the first set, this set up here, are simply opposites. Not reciprocals, not opposite reciprocals, just opposites. This second one that you did are reciprocals, not opposites. And so to be perpendicular, it has to be both opposite and reciprocals. Okay, so that is the end of our section on slope. I assume there will probably be some questions that you will have. So as you have questions, make sure you send me an email and let me know. Our next videos after this will be getting into chapter 4, or chapter 5. So be aware of that. You'll be seeing emails from me